So today we are going to learn about domain and range, and we have two objectives. Our content objective says, I will be able to identify the domain and range from a graph, table, and equation. Our language objective, I will write the domain and range from a graph, table, and equation. So we are going to be talking about our new vocabulary words. As you can see here, it's domain and range. Make sure to have a notebook or something to write with. That way you can take notes as you go through today's lesson.
So when you're writing your domain and range, there's something that you have to decide before you get to write that domain and range. And you have to ask yourself if your data is discrete or if your data is continuous. So what we mean by that is discrete is data that can be counted. So these are things that are wholes. They cannot be broken down. So examples would be the number of students in a classroom, the number of folders you can purchase, or the number of books in a library. So these are all things that are countable things. Like I can only check out one book from the library, not 1.5 a book. I go to the store and I buy a folder. I can't buy half of a folder. I have to buy 1 or 2 whole folders, and so on. So discrete are things that are countable. They're not going to be broken down. Then you have continuous, and this data is data that can be measured. So these variables we can actually break apart. So examples would be a person's height over time, distance over time, or buying meat and veggies at the store. So if you've ever been to the store with your parents, sometimes you'll notice it'll say like, oh, apples are $1.50 per pound. So I don't just buy maybe 1 pound or 2 pounds, but I can also purchase 1.5 pounds or 1.6 or 1.75 pounds of apples. Now, discrete and continuous data, the graphs also look very different. So if you look here for discrete data, this is what discrete data on a graph looks like. So if you notice, you have the data points. This graph is scattered. This graph is in a line. But notice that there's no line connecting the data points. It's all very discrete. It's all very individualized. Okay, kind of like I can only buy 1 folder. I can only buy 1 book or so on. Okay, same thing for that tickets. You can buy 1 ticket, but not half of a ticket. Then you look over at continuous, and we have things like time and temperature on this graph. So at any time of the day, I can figure out what that temperature was, not just 1 o'clock or 2 o'clock, but I can also figure out what the temperature was at 2:45 or 2:26 p.m. or something like that. Same thing for a person's age and height and cost per pound. So the first step of writing domain and range is asking ourselves, is our data discrete or is it continuous? So now let's talk about domain and range. So at the top, you can see the definitions for both. You've got domain, which is the set of all x values that are the inputs of a function. So if you remember from yesterday, Dixie and Royd, I have that written here too at the top. Domain, another word for domain are inputs, x values, or the independent variable. Okay. Over here we have range. Range is the set of all y values that are the outputs of a function. So other words for range are output, y values, or dependent variables. Okay. So as we're going through, we're going to be talking about how to identify domain and range, and then how we write domain and range. So if you look, we have 3 questions: independent variable, dependent variable, and then we also have to determine if it's discrete or continuous. So if I look at what I'm comparing, time spent exercising to the number of calories burned. Okay, well, my independent variable, another word for independent is x values. So that means if I'm looking at a graph, I want to make sure that I'm paying attention to the x-axis, which is down here. So on the x-axis, I have time spent exercising. So that is my independent variable. Then I need to also find my dependent variable. Well, another word for dependent is y values. That means my dependent variable is found on the y-axis, which is the number of calories burned. So now that I've determined my variables, I'm comparing the time somebody spends exercising versus the number of calories burned. So if I'm looking here at my graph, and if I look back to my discrete and continuous notes, this graph looks like a discrete graph. So because this is a discrete graph, the way I have to write my domain and range is I'm going to first write my domain. Domain is the x values, so I'm going to start by saying domain or the x values equals, and then I'm going to put this, it's just like a fancy bracket. So now I've got to look at all of my x values for my data points. So my first data point is right around 1, so I'm going to write that person spent 1 hour exercising. This person here spent about 1.5 hours exercising. This person here spent about 2.5 hours exercising. So I'm trying to list out basically every x value of every data point, and that is my domain. So this is the domain for my data. Now I need to write the range, and the range is pretty much the same thing, but instead of the x values, I'm going to write the y values. So again, I look at every data point and I find the y value. So that first person burned about, let's just say 60 calories. This person right here was about 160 calories. And then I'm just going to keep going back and forth between each data point. So this is our range for our graph. So again, when we have discrete data or a discrete graph, then we are going to be listing out our domain and our range by looking at every data point and listing out the x and the y value. So now let's look at this next example. So again, if you notice at the top, we have the notes and definitions for domain and range in case you forget. Again, domain is the set of all x values. The range is the set of all y values. And we're going to continue to use Dixie and Royd. So I have the same questions, which is independent variable and dependent variable. And then I have to determine if it's discrete or continuous. So on my graph, the independent variable, well, another word for independent variable is the x value. So again, I pay attention to the x-axis. So in our case, our independent variable is time in minutes. And then once I have the independent variable written down, I have to find my dependent variable, which another word for dependent variable is y values. That means I've got to go find where the y values are located, which is on the y-axis. So that would be distance in feet for my y or my dependent variables. So now that I've identified my independent and my dependent variables, I need to now identify whether this graph is discrete or continuous. So from the beginning, from the notes for discrete and continuous, I notice that I do have data points, but it looks like they're connected by a line. So if they're connected by a line, then the graph is continuous. So since our graph is continuous, our domain and range is going to be written differently than it is for discrete. So for our domain, which domain is going to talk about time, I need to find where the line starts and where the line ends, or the time. So the first time, or the very beginning time, is actually at 0. So I'm going to start my domain at 0. Then the time ends at about 10 minutes. So my domain is going to end at 10 minutes. Now imagine if this is a race, right? So somebody is running a race over a distance over time. Well, I could figure out where that person is at 3 minutes, 5 minutes, 7 minutes, 6 minutes, and so on. But I could also figure out where that person is in the race at 3.5 minutes, or at 4.2 minutes, or 4.8 minutes, and so on. So because I can figure out where that person is at any point of this race, because that's what the line shows me, then that means I have to write my domain and my range as an interval for continuous. So what we mean by interval is we're going to use inequalities. So if you remember inequalities from last year, this is a less than symbol. This is less than or equals to. This is greater than, and this is greater than or equals to. So if I notice here, my dots are closed or filled in. So I'm definitely going to have to use one of the equals to symbols. And then the one that I pick is, well, if I look at 0 and 10, is 0 less than or is it greater than 10? Well, 0 happens to be less than, so I'm going to want to use the less than or equal to symbol. And I'm going to use 2 of them because in the middle, I'm actually going to use an X here. Okay. And the X represents domain, because remember, domain means X values. So the way we write our domain and our range is an interval notation. So we have a starting and an ending number. We're using our inequalities to tell us that the time this race took is anywhere from 0 to 10 minutes. So when I do my range, it's really similar. Again, I need my starting range number, or my starting distance, which was 0. And where did this race end? Well, it happens to end at 200 feet. So my interval ends at 200. Again, I need to decide which type of inequality to use. So is 0 less or greater than 200? Since it's less than, again, I'm going to use the less than symbol. And because, again, those ending points are closed, I want to make sure that it's equals to, because I can figure out at any point in the race where this person is. Now, the difference between domain and range, well, domain is the X values, range is the Y values. So in the center, I need to write a Y in between the interval. So because the data from our graph was measurable, we're measuring distance over time. That's why we chose continuous, which is also why we have to write our domain and range as intervals, because we're measuring and we can figure out anywhere in between that time or that distance where that person was in the race. So just a few reminders before we go. Remember that domain is the set of all X values that are inputs of a function. Range is a set of all Y values that are the outputs of a function. So if you have a table, a list of points, or even a mapping diagram, you should be able to determine which numbers are your domains and which numbers are your ranges by deciding which numbers are your independent variables and which are your dependent variables.